All right, welcome to this portion of the stuff. Let's get started. Disjunctions, okay? Some of you may have covered this if you were from the previous class. We talked a little bit before, we talked about this thing called conjunctions, where we had Franco do all the work. Franco was a senior, Franco is a student, and we said, when are those two things true? That would be when Franco is a student and when Franco is a senior. However, we didn't go much past that. And in fact, let's do another example, was not done, but the great thing about this is they're always the same thing. So we can go ahead and use that same pattern here, which is true, true, false, false, true, false, true, false, true, false, false, false. Okay? So we can follow that same pattern. And those two first columns, no matter what the third column is, generally those two things are going to be the same. Okay, you can go ahead and get familiar with that and whatnot. Now, I did want to mention that this, if you were to do this on a test, you will get it completely wrong. And that is, I did it. Okay? That will get you a wrong answer. Okay? So, what is that? True, false? What is it? Doesn't fit. Okay? So if I see that, I'm going to assume that is, I don't know what I'm doing. Okay? So careful with that. Now, this is called a disjunction up here with the upside down V. And those are only a conjunction, a conjunction, okay, with an upside down V. And true, true is the only time that we get a truth for that particular value, okay? It's the only time we get that. The disjunction is something that's a little different, okay? And in fact, if conjunction was an upside down V, and it's the same thing as an intersection, see over here on the board, the intersection is an upside down U, the conjunction is an upside down V. Well, disjunction is a right side up V. Okay? That is a right side up V. And in fact, it's just a regular V. It's a different shape on the computer, and it's called a wedge. But we're going to call it disjunction, okay? Disjunction. So here's an example. Let's have Sarah read this nice and loud for the people on the video to hear. So go ahead, Sarah. Anytime you feel like saying it, you are welcome to read this particular example up there on the board. Go ahead.
Daisy ran the 500 meters today. Daisy ran the 1,000 meter today. The disjunction Q.
And then we're going to write P disjunction Q. Okay? Anybody guess who is Daisy? These are all from last year's IB students. Daisy? Is it Kano? Well, I called her Kano. Whoops. But Kano was a character on Mortal Kombat. Pretty badass. And like Jacqueline, Luna. I call her Luna because of that one show, Harry Potter.
That one show?
That one movie. Okay, so Daisy Kano? Okay. Daisy ran the 1,500 meter today. Daisy ran the 1,000 meter today. A disjunction is true when one or the other or both are true. In this case, Daisy has to run either the 500, has to run the 1,000, or has to run both. Excuse me, hiccups. Also note that a disjunction is only false when both propositions are false. That means she didn't run at all. Bonjour. Mucho gusto. Have a great day. Arrivederci. Okay. There's a lot of languages mixed up there. Okay. So, let's write one. That's why I sat down. Let's write one of these. So, what is it going to be? Well, Daisy, we're going to write Daisy Chain ran the 500 meter or the 1,000 meter today. Okay? And that's it. Oh, wait a second. That looks awfully a lot like unions. You remember unions? It was one or the other or both. That's what that means. Disjunction means one or the other or both. Okay? Great. I think we're getting it. Let's look at an example. Okay? You already filled it out.
Is it right?
Yes, it is. So let's figure out the truth value to these. And to the truth value, we're going to plug it in and do a truth table. Here it is. So this is for P or Q. Now remember what I just said. Those two little statements. And how about with those two little statements, you're going to postulate what would be the truth table for that. Take 30 seconds to fill that in. See?
With truth tables, can we use ones and zeros if he's not?
Absolutely not.
Darn.
No ones and zeros. We're not doing binary here. But I like it. You're not going to ever do that on an IB exam, so the answer is no.
Alright.
Don't get used to that. After the IB exam, ones and zeros all day. One time my friend and I, we learned binary. We didn't really learn it, but we would send each other texts in binary. They would be like 70 characters long. 700 characters long. And I would say like, "What's up, man? How you doing?"
Or just hi.
It's just like, no, hi is.
I don't know why he would.
We didn't really learn it. We just said like, "Hey man, what's up? How you doing?" And then we do a translation because it'll translate it into binary, and then send it over. So it's like code. It's pretty cool. And then we translate it back. Yeah, but it's code. It's like encryptions. Let's see, Maria. What's the first column? The first column.
Oh, it's true, true, false, false.
Good. True, true, false, false. Second column. You are the gem of gems.
One of the librarians said, "Don't do that again. You have way too many people."
Was there too many people there?
No, too many. Like, that's too big of a load.
She really said that?
Yes.
Which
You
one,
can't
curly
do
hair?
worse with that. No, blonde hair.
Was she like,
brown.
she kind of joking?
I mean, I wasn't.
You what?
I would not have been joking. That's so wrong.
But teachers do that all the time.
Cry me a river.
You should send that to
That's what I
the
say.
shop.
Yes, I should have sent it to the print shop,
That's
but
her argument. Just do that.
okay. I just, I don't.
I know.
The print shop closes at 3:30, and so like I get done. You guys stick around till like 3:50, and then I'm like, oh crap. I'll just do it when they're not looking. I should have printed out at last night after the study session.
Are you recording the class?
Oh crap! This is now recorded. I'll have to do a little editing. Nobody's recording video, right? Okay. So anyway, PQ, PVQ. I only printed out 24. I could have printed out 44 because I have another class that has to pass it.
Move on.
Sorry. Okay. So it's good. Let's do this. Sorry about that, everybody. True, true, false, false. Next column is what, Linda?
True, false, true, false.
True, false, true, false. That's true. And then the final column, what do you think? How about Kim?
True, 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 false.
Good job, Kim. One of them has to be true for it to be true, true, true. And the last one had nothing, so it's false. Okay? All right. That's disjunction. Cool. Now there's a Venn diagram associated with that. I'm going to fly through this because we already know Venn diagrams. Okay? A Venn diagram indicates that both of those are the truth sets of that. Okay? So it points to P and Q, and the truth set is P, and the truth set is Q. And so P VQ is all the truth values of those. Okay? So it's pretty straightforward. Union. Same thing. Okay? The difference between little p and big P is big P is the set of values and little p is the truth set of values. Okay? Alright. Now there is another thing that is called the exclusive disjunction. Exclusive disjunction says it is only true when only one of the propositions is true. The exclusive disjunction of P and Q is written as P V underscore Q. Okay? And that indicates that we want one, the other, but not both. Okay? One, the other, and not both. That is what exclusive disjunction means. Write that down on a note slide. Note card. Note card. Okay? So, Orion is our example. Who is it? What? Good job. Point. You get a point. Okay, that's Orion Suitor. We can describe P V underscore Q, which is P or Q, but not both. That's kind of like the definition right there. It's P or Q, but not both of them. Or exactly one of P and Q. Exactly one, but not both. Okay? So, that should be not Sally, that should be Orion there. Okay. Orion ate cereal for breakfast. Orion ate toast for breakfast. We are not talking about Sally. Sally wanted to join the fun. So what does this truth table look like? Ooh, here you go. Fill it in on your own. Caitlin, first row, what do we get? True, true, false, false. Then we get what? A trinity. Next row, next column.
Skip me.
Skip me. True, false, true, false. And then last column, we have to decide which one is true. Cody Moore.
False, true, true, false.
Nice. False, true, true, false. And that, like these that I'm giving you, are the truth tables for that particular event. Okay? It doesn't matter if Orion ate cereal or Orion went skydiving or Sarah had a dog or whatever. It doesn't matter. This will always be true, true, false, false, true, false, true, false, false, true, true, false. That's what it will be. Okay? Just said that. Okay? Just said that too. Okay, so dang, it's a Sally again. It's kind of a repeat slide. Orion. It was the original question that I stole. Then I changed it to Orion. If P and Q are the truth sets of the proposition for P and Q respectively, then the truth set of P V underscore Q is the region shaded where exactly one of P and Q is true. Okay? So, there it is. Now I think it says PVQ if and only if P union Q minus P. This is supposed to be an underscore. Golly, Jehoshaphat. Who wrote this? I know. Ah. Just gonna copy and paste it. There we go. Okay. Ah! No wonder why I did that. There. This is supposed to be underscored as well. Oops. This is going to be a great video.
Oh, shoot, I forgot.
Okay. There we go. So it looks like this. And once again, that truth set, wow. That truth set is true, true, false, false, true, false, true, false. That would give me a false. And then false, true, true, false. Okay? Okay. Moving on. Let's continue. So, we are now officially, we're like back and forth in these two classes right now. Okay, so let P be the truth set of the proposition P and Q be the truth set of the proposition Q. Okay, use mathematical logic to express the following shaded regions in terms of P and Q. Okay, so we have a couple things that we can do. We can do negation, we can do disjunction, we can do conjunction, and we can do exclusively disjunctive. Disjunctions. Disjunctive. So we can do those three things. Now the negation can be added into all sorts of different things. So for instance, let's look at A. A is every single thing shaded here, except for the outside. That would indicate that we have P, V, Q. And we're doing P, V, Q. Okay? That's what that indicates. Both are true, and every single one of them is true. Now, if you look at B here, everything is done except Q. And before we would do something like Q, capital Q prime. But that's the truth set of the proposition. The proposition is Q. So if we were to do the same thing that is equivalent to the proposition, we would say it's negate Q. Okay? And then the last one here says only Q is true and not both. Okay? You could do this in a couple different ways, but the way we're going to do it is we're going to find basically what this is as a union. Okay? How would I do this as a union? Well, that would be, or not a union, but as a Venn diagram using set theory, unions and intersections. This is the intersection of not P and Q. Okay? So this would be, for instance, not P intersection Q. You see how that would fit right here? Okay? That would be true. And that ends up being negate P, and that's called a, I forget, there's a name for that, conjunction Q. Okay? Now you could notice that this could be Q minus the intersection of Q and P. Do you see that? That is exactly the same thing. However, we're trying to write it as one specific statement, so there is a simpler way to do it. That would be this over here. Oh, you know what? All the answers are right here.
Yeah.
Oh, heck.
Well, that's great. Did the work. So now we're going to talk about more of a truth table scenario. A truth table scenario doesn't just have one truth item. It usually has multiple truth items, like disjunction and conjunction. or negation and not negation, or something like that. So I want you to fill in your P's and Q's, fill in your negate P, fill in your P intersection Q, fill in your P disjunction Q, and then fill in your P exclusively disjunction Q. Okay? You do that all on one table. The worst thing is I gotta go print some more stuff over there. So some of you are kind of stuck on negate P. What is negate P? If I say true, what is negate P? False. So whenever you put true for P, negate P, you're going to put false. And whenever you see false, you're going to put true. It may be kind of redundant, but that's how the truth table is set up. Okay? You will have to do that. Good job. Except for this last one.
Yeah, isn't that one really true?
Nope. Yes, it would.
Okay.
It's true because P is false. Yep. Yep. There's an echo right here. In mid-conversation, I recognized the echo. Somewhere right there. Okay, let's do it. It could be the way the people were positioned in the class too. It really worked out. Okay, here we go. Follow along. I'm going to do this very fast. True, true, false, false, true, false, true, false. Now the opposite of P. False, false, true, true. I itch. My eye itches, not I. People online will be like, what did they say? Okay, intersection is what we're looking at. So conjunction, true, false, false, false. Okay, wedge or union or disjunction, that is true, 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 false. And exclusive is false, true, true, false. Universally, those are always true. That could be like your little cheat sheet. You just need to know what these symbols mean. Know what the symbols mean, okay? Oh, look, they're up here. Negation, conjunction, disjunction, exclusive disjunction. Okay? What would have been really smart if I did negate Q? Who could tell me what negate Q is off the top of their noggin? Caleb? That's right. It would be the opposite. You could write it right here. It's on the next slide. Great. Okay. So so fill in the first three, and then we'll talk about the fourth one in a second. First three columns. All right. So, what's interesting about this is we're going to fill in everything. It's really easy. True, true, false, false, true, false, true, false. And it's basically asking us to figure this out. So to figure this out, we also need to write negate Q. So generally when you are asked to construct a truth table, the truth table will be P and Q, and then whatever you're going to figure out. Now we need to figure out negate Q, and thanks to Caleb, we've done that. That is false, true, false, true. Remember, it's the opposite of Q. Okay? But now it says P intersection negate Q. Now, before we would have to go, oh, what does this look like on a Venn diagram? But we know something about intersection. What do we know about conjunction one, conjunction another? What? It needs to be true, true. So it doesn't matter what it is. P and Q, whatever. True, true is what we're looking for. So we can go through this, and we're going to now basically completely ignore Q, and we're going to just look at the truth value of P and negate Q. Do we have true, true there? No. Do we have true, true here? Yes, so that's true. Do we have true, true here? No, that's false. And do we have true, true here? That is false. Okay? So you can see that the use of disjunction can be between not just P's and Q's, but negate P's and negate Q's. Okay? Any questions about that? All right, let's continue. So what is a tautology? Here we go. Good. Here's a new word. You're going to learn a new word today. Let's have Elena read that for us right there and there.
A compound proposition is a tautology if all the values in its truth table column are true. A compound proposition is a logical contradiction if all the values in its truth table column are false.
Good. Okay. So, tautology means that the entire column is true, and a logical contradiction means all of the values are false. Now, remember when I was actually telling you these propositions and we were doing them? We are now in the abstract realm. We're just talking about a P and a Q. We're not talking about what is the proposition P and what is the proposition Q. We're just saying P and Q are going to have different truth sets, and those truth sets are going to be true for certain things and not true for other things. Logical contradiction. That means it's completely backwards. Okay? A tautology means it's basically logically valid. We'll come back to that statement. So here it is. We have P P conjunction negate P. Okay, let's decide if that's a tautology or a logical contradiction. Okay? So what are our truth statements here? Well, we have true, true, false, false. We don't necessarily need to write them like that, but we're pretty used to writing true, true, false, false. So let's go ahead and continue doing that. And negate P is going to be the opposite. So Molly, what would that be? False, false, true, true. And Molly, since it looks like you've already finished it, what would our last column be? False, 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 false. This is a logical contradiction. Okay? That truth set at the very end is not the answer. The answer is an interpretation of that truth set. A lot of people on a test or something, they go false, 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 false. Yay, I'm done. No, you have to be like, what does that mean? IB wants to know that you know that that means a logical contradiction. It's like saying, I am going to the store and I am not going to the store. Okay? Well, those are contradicting of each other, aren't they? Okay? That would be kind of the verbiage of P and Q. Ben, you liking this stuff? I thought you would. Okay, let's do some more. Let's do some more complicated ones. Okay? So I've done the first two columns for you because these are pretty universal. Okay? P, Q, negate P, negate Q. And now I want you to go through and I want you to look at that first one and I want you to decide what are its truth sets. Okay? So you have to understand the symbol And then you have to understand the two things that are being compared within that symbol. So that's negate Q, intersection P. What does the upside down V stand for? It's conjunction, which means we're looking for true, true as the only truth. True, true is the only truth out there. Okay? For that particular one. The next column we have the V. The V is like or, okay? It is saying that I am disjunctive. I can have one or the other or both. Okay? So you can fill that in as well. But you look at the columns that are appropriate. And then the last one, it's got a few things. It's saying, hey, take one column that I've already filled out and another column that I've already filled out and compare those two columns. Okay? So you can see how this can get complicated. We're saying, well, let's fill in the first two columns here. I know it's right behind it, but still. Is it? Oh, there's one. There's the other. Not going to do it. Okay, so what's that first column, Caleb?
False, true, false, false.
You say false, true, false, false. Let's see if we match. Ding, 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 ding. Not going to do it. How about the next one? I haven't talked to Kara Miner.
I got false, false, true, false.
False, false, true, false. Let's see. Oh, ding, 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 ding. Uh-oh. Oops. Looks like this one we need a little bit of work with. So here's what we're going to do. We're going to put stars above the ones that we want to compare. We want to compare Q, and we want to compare negate P. Okay? If we compare those, every single time we get a truth in one of those two columns, it's true. So that tells me true. That tells me true. That tells me true. That tells me... Oh, I missed this one. Sorry. I was looking at negate P. And true. Okay? So now what we're going to do is we're going to figure out the intersection of those two. The intersection of those two columns. So I'll do this in another color. How about purple? We're going to look at this, and that will be this column. Does that make sense what I'm doing here? Okay, I looked at these two columns for this, and now I'm looking at these two columns to get my answer for this. And that one would be the intersection of this and this has to be double truths. And I see false, 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 false. Okay? There it is. Which shows that these two things are logical contradictions. They aren't always opposites of each other. Now we could do the same thing here. I mean, I could do a little extension here, and I could do the same thing, but I could go negate Q, intersection P, and if I did disjunction Q, disjunction negate P, what would it be then? So we're going to compare these two things and figure it out. We're going to take all of these, this and this, and we're going to construct this, but instead we're going to use the wedge. Okay? What do we end? And we can even use exclusive disjunction if we want. What would we get, Ben?
Tautology.
We would-
all be true.
They would all be true. That is a tautology. Okay? Interesting. So there's a lot of options that I can give you on these problems. Okay, I think this is going to have you do one on your own. Two propositions are logically equivalent if they have the same truth table column. So let's look at these two. This is negate P intersection, intersection Q. I keep saying, I should say conjunction. I'm going to say those two things in order. Now look at this. It's like, wait a second. How do you do this first one? Well, the first one is kind of done pretty cool. What we do is we figure out what P conjunction Q is, and then we decide what the negation of P Q is. So P intersection Q, that's always true, false, false, false. And so what would our ending value be here? What do you think, Sarah? Oh. Yeah? Yeah, it's the opposite. False, true, true, true. Okay? Now we're going to show that this is actually logically equivalent to our other statement, which is negate P union or disjunction negate Q. So I'm going to put a column here, I'm going to put a column here, and then I'm going to put those two things together. Now here's what I'm going to do. I'm going to do negate P, I'm going to do negate Q, because those are two things that I'm going to look at comparing. Okay? And then I'm going to do negate P, negate Q, it is. It's just yellow. Is that better? Negate P, negate Q, negate P, Q. That's okay. All right, so let's continue. So we have false, false, true, true. JK, not. Oh, that was funny. Okay, false, false, true, true, false, true, false, true. Wait, how do I know all that? Because I'm looking right here. P, opposite of P is that. Opposite of Q is that. And now we're going to go ahead and look at those. This was T. Look at those together. We're going to say, when do we have a true anywhere? It looks like it's going to be false, true, true, true. And these two things are logically equivalent. It doesn't mean that they're the same statement, and it doesn't mean that the statement follows any sort of rules. It just means that the statement's truth values are the same. Okay? It follows the same pattern of truth values. One last thing in C. Oh, look at this. I have all the answers. There you go. Now you can see them better. Oh, look at what you do. Wow, that's a lot of waste of time. There we go. Logically equivalent. Oh, there's that too. What do you know? Hot dang. So these are saying that the statements are logically equivalent. Okay? That's what that means. They are logically equivalent. Let's do one alone. Okay, do one alone. I set up the truth tables. You need to fill it in. Have you already done it? Who's not done it? Okay, bust it out. Breakdown of the symbols. 3 propositions. Okay. Why are there earrings in the corner? It's probably National Earring Day, and I didn't know. I think Siri will tell you what the national day is. What is the national day today?
I Sugar lumpkins. I'm afraid I can't answer that.
What did it say?
Calls me sugar lumpkins. What is the national day today?
National Day is on Saturday, July 1st, 2017.
What is the recognized holiday for today?
Today isn't a holiday. Not here. Anyway.
Wow, you're really helpful. Oh, I'm still recording. Let's continue. Here we go. Construct it. Quickly. Let's start with Ben. First 3 columns.
False, false, true, false, and the third one, false, false, true, true.
Nicely. Oops.
National High Five.
Yeah, National High Five Day.
Oh, cool.
Line beam respect.
I'm glad you all got on your cell phones. All right. So now what we're doing. So be aware that we are going to compare negate P and Q. But we are going to look at this and then that. Now that's an important statement that I just made while you were talking. I am going to look at them in order. That is important. Okay? When we get to further things like figuring out if and only if statements and if statements, if then statements, it is important that you know where you start and where you go. So I'm going to purposefully say this is true, false. An intersection would be false. Okay? Here, I'll get a nicer color for you. Yeah?
Why are these false, true for the third column?
Oh, it should be false. True. My bad. That was negate Q. Okay? I did it wrong, didn't I? Thanks, man. So, we're looking at this and then this. That is false, true. That's false. Okay? We're looking at the wrong ones. Good job, but whatever. It's not that one. It's this one. So, false, true. That's false. False, false. That's false. True, true. That's true. True, false. That's false. Okay? Good. So, here's the symbols. Okay? And we can go ahead and here's a little breakdown. It says when we have a conjunction, we need true to have a truth. We need both to be true to have a true. Okay? So we're looking for true, true. That is a truth. One or more need to be true to have this. Remember, that is true, 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 false, basically. That's that column. This one would be true, false, false, false. For our basic P and Qs. Only one can be true to have a truth. That's what this one means. That is false, true, true, false. And then lastly, negate is the opposite of whatever it's in front of. Okay? You can't really write anything about that. Okay. Oh, good. So we are going to talk about 3 propositions. Are these all filled out for you? Well, that's great. Now, these ones are a little bit weird, but they do follow a pattern. Now, you could go through, it could be, okay, let's start true, 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 and then let's go, how about true, false, true, and then let's go. No, there's an actual pattern that you can do. Okay? The pattern is true, 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 false, 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 true, true, false, false, true, true, false, false. Wait, I'm saying them. True, 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 false, 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 false. True, true, false, false, true, true, false, false. And then true, false, true, false, true, false, true, false. You record that, sample it, make a rap. Okay. So, R is used as a third proposition. You can do these. I've seen these on the IB test, so these are important. Okay, but you just compare them like you've done with every single thing. Okay? So it says you try to construct a 3-proposition truth table with this. Now, let me set it up with you. So we have, what do you want?
I need a shortcut for a dot product in Word. I'm really upset about it.
/bullet.
That's for little book. Like, I don't want like a product. I want like a dot product.
What is that? I don't understand what you're talking about.
The product of the components of the vector of their sum. The dot product. Like a big old fat mother of dot.
The mother of dots?
Yeah, like a big old fat mother of all dots.
I am recording right now, but I am recording, but there's this thing called Google that you could look at. Did you try that?
You guys have a great day. Go Google it. Just gotta use all these shortcuts.
Well, I do. So hold on. I can do this. If you do that, and then I go to these symbols right here. Come here. So these symbols right here are going to indicate all different types of dots and
Oh,
stuff.
I did that.
And you go basic math. There's also these as well. Operations. I don't see. Is there any in here?
No.
Okay, if there's not one in here, then you can't do it. So you check all of them. Sorry, check all of them.
Yeah.
You've
And
checked.
if I make the font bigger, the letters get bigger, so it looks stupid.
You could.
Yeah, you just highlighted it.
I did that, but it keeps getting bigger.
How about this?
Like everything around it.
Oh yeah,
Because I'm in
yeah.
that stupid math scripting. And
The best thing I would say is to do a insert text
Circle.
box.
I can insert a little circle.
Make a text box. Then you do /bullet, and then you
Take
take
that bigger.
make that bigger. Home. Ba, 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 ba. It would almost be as beneficial to do insert shape
Circle.
circle. Yeah. Good talk. Have a great day. What were we doing?
We're doing 3 propositions.
3 proposition. Yes, yes, yes. 1, 2, 3, and then that, and then that. Okay, yeah, we can do it. Okay, yeah. There. Sorry, maybe I shouldn't make it those black next time. Do it right above. Just put P, put Q, and put R, and then we have to create one and then compare it to the other. So we're gonna do PVQ, and then we're gonna do the whole thing PVQ and wedge R. I'm gonna start using just the word wedge. It's easier. Okay, so we're doing disjunction, and then we're going to figure out the conjunction. Okay? So you can do it right up there. Got it, Colin?
Got his name down?
Get off your phone.
Come on.
All right, Caleb. Or whenever I forget. Sugar lumpkins. Where did that come from? Here we go. First column is true, 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 false, 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 false. And then we have T, T, F, F, T, T, F, F. And then we have T, F, T, F, T, F, T, F. And now we get to the good stuff. So, fill it low. Quiz, Sydney. What's the next column?
True.
Whoa, whoa, time out. Slow down. Okay, keep going.
True. False.
False, false. Okie dokie. So the last column, we take this column and compare it to R. When now what are we looking for when we have this symbol? Two truths. Okay? So let's do it. Let's compare this symbol here and these symbols here. And remember, we'll try to remember to do it in order. So true, true? True. Not a good color. So I can't use yellow, I can't use orange, and I can't use light green. How about light blue? Yeah, okay. Next one. False. Next one. True. Next one. False. Next one. Next one. Next one. Next one. Yay, that was great. That was fun. Holy bajoli. There's your homework for tonight. Well, you guys should have gotten started on the first portion.
We know you didn't give us the first.
Yeah, I said these. Yeah. Oh, but throw those away.
Okay.
Yeah, that little packet that I gave you, that was for people who wanted to be responsible.
Wait till what we go.
This is the book. A waste?
Wait, did you not put in the air?
Back to the book that's on my website. So whatever I gave you before, you can go ahead and recycle that. It was only like 2 or 3 pages. So.
Wait.
Yeah, hold on, I'm gonna make it. Oh, no. Wait, stay there, stay there, stay there. So if I miss it, now I can do whatever I do. Okay, here.
Okay, hold on, time out. Shh. You also had homework from the previous section. So
You missed!
you also had
I was getting ready.
okay. You also had homework from the previous section that apparently that I didn't collect.
We didn't even go over it.
We didn't even go over it, but we do have a little bit of time. I did want to get started on the new packet. I know, way at Crimey River, we have a test coming up. You need to know this stuff. We don't have enough time. Sorry. So, let's get to the homework. I'll allot 10 minutes for the homework. We're going to get started on the next section. Because technically we should, according to my calculations, we should be done with the next session. So we got to hustle. That homework right there. So,
Yeah, what about the recording?
recording. Thank you, F10.